When you're looking for a laptop to handle artificial intelligence and machine learning tasks, the most important component is the graphics card, specifically its dedicated video memory, or VRAM. Modern deep learning models, like the large language models behind chatbots, need to sit entirely inside this video memory while they train or generate answers. If the VRAM is too small, the work either slows to a crawl or simply cannot be done. For real-world AI projects, 8 GB is the bare minimum. 16 GB lets you work comfortably with much larger models, and 24 GB opens the door to serious, large-scale experimentation. Beyond the GPU, you want a fast processor with many cores to prepare and stream data, at least 32 GB of system RAM so your datasets fit in memory, and a quick NVMe solid-state drive that loads files without bottlenecking the graphics card. Gaming laptops happen to pack exactly these kinds of parts into portable packages, so they have become a favorite among AI developers who need to work on the move. And in this review, after analyzing dozens of laptops, we've selected the best laptops for AI and machine learning. Our picks start with a strong entry-level option, capable of handling model training, development, and experimentation, and work all the way up to powerful workstation-class machines designed for demanding AI workloads with virtually no compromises. As always, links to every laptop featured in this video can be found in the description below. And be sure to watch until the end to find the perfect option for your needs. Now, with that out of the way, let's dive into the list. The first laptop on the list is the ASUS TUF F16. This laptop comes with an NVIDIA GeForce RTX 5070 graphics card that carries a dedicated 8 GB of fast GDDR7 video memory. That amount of video memory is perfectly fine for learning, running smaller open-source models, and experimenting with frameworks like PyTorch or TensorFlow. The processor is an Intel Core i7-14650HX, a chip with plenty of cores to handle data pre-processing without making you wait. You also get 32 GB of DDR5 system RAM and a generous 2 TB of SSD, which gives you a comfortable playground for moderately sized datasets. The 16-inch Full HD Plus display uses a 16:10 aspect ratio, giving you a little extra vertical space for scrolling through code, and it includes a MUX switch, which lets the dedicated GPU talk directly to the screen for better performance and lower latency. This machine is a sensible and affordable starting point for AI students or anyone who wants to learn without spending a fortune. Moving up the stack, the Razer Blade 16 represents a massive leap in AI horsepower. Instead of an RTX 5070, you get an RTX 4090 with 16 GB of video memory. That doubling of video memory immediately allows you to load models twice as large, fine-tune more ambitious language models, and train neural networks significantly faster thanks to the huge number of processing cores inside the 4090. The processor also jumps to a top-tier 14th generation Intel Core i9-14900HX, which makes any CPU-heavy data crunching even faster. The memory and storage stay at 32 GB of RAM and a 2 TB of SSD, but the display receives a stunning upgrade to a 16-inch OLED panel with Quad HD Plus resolution and a 240 Hz refresh rate. OLED technology means every pixel is its own light source, delivering true blacks and incredible contrast that make long coding sessions easier on the eyes. The Razer Blade also wraps all this power in a sleek, all-metal chassis that is surprisingly thin, making it a premium pick if portability and build quality matter as much as raw speed. If you love the idea of the Razer Blade's core components but wish for an even larger workspace and more thermal breathing room, the Dell Alienware M18R2 delivers exactly that. It shares the same Intel i9-14900HX processor and RTX 4090 with 16 GB of video memory, but it houses them in a huge 18-inch body. The display is an 18-inch Quad HD Plus panel with a 165 Hz refresh rate, which is not quite as fast as the Razer screen, but provides dramatically more physical area. That extra space is a blessing when you have your code editor, a terminal, documentation, and GPU monitoring tools all visible at the same time. The larger chassis also allows for bigger fans and superior cooling, so the laptop can sustain full performance during a multi-hour training run without becoming excessively loud or hot. You do sacrifice some portability, but if your laptop mostly stays on a desk, the Alienware feels like a true desktop replacement. Stepping into the next generation of hardware, the ASUS ROG Strix SCAR 16 from 2025 introduces a completely new platform built around NVIDIA's latest graphics architecture and Intel's fresh processor design. This machine packs a GeForce RTX 5090 laptop GPU with a full 24 GB of GDDR7 video memory. That moves you straight into the top tier of mobile VRAM, allowing you to load enormous language models, train with larger batch sizes, and comfortably keep complex neural networks entirely in fast video memory. The RTX 5090 also brings updated tensor cores, the specialized circuits that accelerate the matrix math at the heart of AI, making training and inference more efficient. The processor moves to an Intel Core Ultra 9 275HX, which adds an integrated neural processing unit, or NPU, alongside the usual CPU cores. That little NPU can handle lighter AI tasks, like real-time background blur, without waking up the power-hungry GPU, which helps battery life. You still get 32 GB of system RAM and a 2 TB PCIe Gen 4 SSD. The display is a 16-inch panel with a taller 16:10 aspect ratio, 2.5K resolution, and a 240 Hz refresh rate, backed by ROG Nebula HDR technology that uses mini LED backlighting for high brightness and vivid HDR contrast. If your AI work demands the most advanced GPU platform with a generous 24 GB of video RAM, the SCAR 16 delivers it in a focused, high-performance package. The Lenovo Legion Pro 7i Gen 10 takes that same incredible RTX 5090 GPU with 24 GB of VRAM and builds an even more expansive ecosystem around it. The processor is the identical Intel Core Ultra 9 275HX, so you still get the helpful NPU and modern hybrid core design. But where the Legion really separates itself is in the system memory. It doubles the RAM to a generous 64 GB while costing almost the same, which lets you preload enormous datasets entirely into memory, avoiding slow trips to the storage drive and keeping the GPU fed with data without any slowdown. The 2 TB of NVMe storage are split across 2 drives, keeping things fast and giving you flexible storage management. The display moves from mini LED to a 16-inch WQXHG OLED panel, pumping out 500 nits of brightness, offering the perfect black levels and superb color accuracy that OLED is known for, all in a 16:10 aspect ratio. Essentially, you're getting the same top-tier AI engine as the SCAR 16, with double the system memory, an OLED screen, and a storage layout built for hardcore multitasking. This is the machine you choose when you want the maximum possible headroom in every part of the laptop, not just the GPU, so that hardware never becomes the bottleneck in your workflow. There you have it, our top 5 picks for the best laptops for AI and machine learning. As always, links to every laptop featured in this video are available in the description below, so make sure to check them out. And if you found the video helpful, consider giving it a like and subscribing to the channel. Thanks for watching, and we'll see you in the next one.